Hello, my name is Sean Broyhill, and I'll be doing a presentation for HCI 521. The topic of my presentation is Computer Programming, Gaming, and Cognitive Development. For this presentation, I took a look at 4 different papers, researched them, and kind of summarized them to pull out how they apply to this topic. The 4 papers were on the cognitive effects of learning programming, review on teaching and learning of computational thinking through programming, what's next for K through 12, patterns of digital game playing in early adolescence, relations to depressed mood, and exploring the educational possibilities of computer games for 7th grade math. That narrowed down to 4 different topics that all were interrelated into the one core subject that I'm looking at, which is the 4 topics on the screen there: cognitive effect of computer programming, computational thinking through game programming, games, how do they affect emotional development, and game interaction in education. So delving into the first paper that I looked at, the cognitive effect of computer programming, one of the main questions that we were trying to look into when looking at this paper were, does implementation increase performance in other subject matters through the thought processes instilled through the type of problem-solving skills used in game programming? This paper was kind of looking into a previous paper called Microcomputers in Education from 1981, hoping to expand upon it to see if that idea could be quantified. P. and Kurland are the authors of the cognitive effect of computer programming, and they presented 7 different changes of thought that became present when a child is taught computer programming. The 7 thoughts are as follows. Rigorous thinking, precise expression, recognize need to make assumptions explicit, since computers run specific algorithms. This helps the child when they're looking at solving the problem. They need to make everything out on the table. They can't just assume things. They need to make everything very explicit. Just like in a computer, the computer doesn't make assumptions. If the information is not there, it can't process it. Second, understanding of general concepts such as formal procedure, variable functions, and transformations. Those are things that are used in program. So what this is doing is pretty much formalizing the thought process being used for other areas outside of programming. Greater facility with the area of heuristics, explicit approaches to problems useful for solving problems in any domain, such as planning, finding a related problem, solving the problem by decomposing it into parts, etc. This is helpful because programming provides highly motivated models for principal heuristic concepts. The general idea that debugging of errors is a constructive and plannable activity applicable to any kind of problem solving, since it is so integral to the interactive nature of the task of getting programs run as intended. So what this does is it allows children or the person attempting to learn an area outside to really look at the problem and to try to find within that problem where the error is, and to have a plan of attack on how to figure out what the problem is and to solve that problem. Also, we have the general idea that one can invent small procedures as building blocks for gradually constructing solutions to large problems. The core concept of object-oriented programming is the building small building blocks that all interchange together to build big ones. So now, instead of a child going into a problem outside of programming and just trying to tackle the problem as a whole, they can look at small solutions within that problem, put them all together, and solve the overall problem through a different kind of thought process. Generally enhance self-consciousness and literacy about the process of solving problems, to the practice of discussing the process of the problem, solving and programming by means of the language of programming concepts. We also have enhanced recognition for domains beyond programming, that there is rarely a single best way to do something, but different ways that have comparative costs and benefits with respect to specific goals. So now we're learning the difference between a process and a product. So there's never a single best avenue. There's multiple different ways that you can solve problems, and that can be applied outside the computer world as well. Going into the next paper, review on teaching and learning of computational thinking through programming, what is next for K through 12? The first thing that they want to answer really was, what is computational thinking? Computational thinking is an algorithmic thinking with automation tools and data representation within the use of simulation. So we're not necessarily solving it the way that we would normally solve a problem. We're using a more automated or data representative methodology of thinking. Lyle and Co. in 2014 classified this as representing a universally applicable attitude and skill set to everyone, not just computer scientists, would be eager to learn and use. So with this, this is a little chart that kind of breaks it down a little bit of what computational thinking is. You have computational concepts, which are concepts that programmers use, such as variables, loops, or you have computational practices, which is a problem-solving practice that occur within the process program, such as being incremental and iterative, testing and debugging, reusing and remixing, abstracting and modularizing. And then the third area of computational thinking, which is computational perspectives, which is a student understanding of themselves, their relationships to others, and the technology world around them. So that's stuff like expressing and questioning about the technology world. So you have those three different subtext of computational thinking. And when they approached the K through 12 program, what this study actually did was they went out and they looked at a bunch of different studies, 27 in total, and quantified the results to determine whether teaching computer programming actually provided a benefit to children. And in reality, it was actually to children as well as some higher education, but I'll get into that later. So on the left here, we see a traditional language, such as Java, which is all text-based. It's very unless you know the actual language, it could become a little bit more difficult to use. Well, in this program, what they did was a more visual programming-based language, such as Scratch, where it actually put in those building blocks, which is kind of described in that first paper. Again, they did a review of 27 different studies, utilizing a range of student ages, curriculum, and profiles. There were the three different types. You have computational concepts, practices, and perspectives, as previously mentioned. They attempted to find then an optimal medium for learning, because the original goal of this paper was actually to see which way was the best to actually teach. However, they found out after doing this study was there is no actual optimal teaching method. Different students could have different results with different applications. So one student may be better at one application, one student may be better at another. There is no true optimal medium. The languages that were used were all visual-based languages such as Logo, Scratch, Toontalk, and Tinker. There are 9 K through 12 studies, 18 higher education, and 3 of the higher education were more of a descriptive statistics without any actual pre or post evaluation. All 9 K through 12 studies showed improvements between control group and study groups, and the higher education groups all showed improvement with an exception of 3. The article did want to go in and explain that they thought since those 3 actually spent less time on programming tasks than the other 15, that could have actually contributed to no marked improvements. There was no decrease in those studies, there was just no increase. The next paper was more of a smaller paper, just talk more about adolescents and their emotional environment with interaction, emotional environments, interactions, and states after playing a games. And they determined that kids that play games are happier, they have a more positive emotional environment, positive interactions, positive states, and a positive emotional state lends to a better cognitive development of the child. A happier child is a child that develops better. Very brief, I just thought this was a nice paper, just kind of tie in that a positive environment can affect cognitive development. And last but not least, we explored the educational possibilities of computer games for 7th grade math. Do kids that play computer games as a supplement to a standard educational practice experience improved developmental skills? That's the whole goal of this particular study. The experiment was conducted to determine if children experience a higher level of understanding by supplementing games, and the results indicate that a positive t-test results was discovered, indicating that students had scored higher on average after a video game interaction than before. And that improvement was a significant increase in the study. One interesting fact, however, was that students actually answered less questions in the time allotted after the video game interaction than before, but they still scored significantly higher. The authors of the paper theorized that that was due to an increased awareness of what problems one does not master, so they're thinking a tad bit more about the problem in an attempt to solve it after playing the interaction than before, so they were able to successfully answer more correctly, but just not answer quite as many. To tie it all together, all 4 papers, games and computer programming have been shown in multiple studies to potentially improve the cognitive development of a child. However, very little research has been done to tie the two together, so future research could provide very valuable tools to determine the effectiveness of tying everything together. And no single solution solves every problem. Some students reacted better to one form of development over another. If implementing this solution into a classroom, more research would need to be done to discover the best implementation plan to help all students available. I thank you for listening to my presentation.